All right, so we've got a whole mountain of Ethereum stuff here, a lot to dig into. But that's what we do, help make sense of it all. Really get to the heart of what Ethereum is really all about.
Yeah, and not just what it is, but like what you can actually do with it. I
Right.
mean, the potential is kind of massive across so many different areas.
Totally. Yeah. Like, think about it. You can build apps, you can manage money, and it's all without needing like the typical gatekeepers, like your banks and governments and all that. But how does it actually deliver on that promise? That's where I need some help. And luckily, I've got our expert here to help us figure it out, separate separate the hype from the reality.
Well, I think the basic idea, the core idea, really comes down to decentralization. It's all about shifting control away from these centralized institutions and giving it to a distributed network
Right.
where no one single entity has all the power to make the rules, you know?
Okay, I get that in theory, but how does that actually work in practice? Like, what makes Ethereum different from, say, just using Bitcoin?
Well, the key difference is that Ethereum is programmable. So Bitcoin is mainly designed for, peer-to-peer payments, right? But Ethereum, it's like this giant open source platform, and you can build all sorts of decentralized applications on it, or dApps as they're called. And the real magic here, though, that's something called smart contracts.
Ah, smart contracts.
Yeah.
It sounds very futuristic, but I'll be honest, I'm still a little fuzzy on what they actually are. Is it like coding a lawyer into every agreement or something?
Uh-huh. That's a pretty good analogy. Smart contracts, they're basically like self-executing agreements, right? Written in code and stored on the Ethereum blockchain. Imagine you want to lend someone some money, but you want to be sure they'll pay you back on time, right? Well, you could put all the terms of that loan, the amount, the interest rate, the repayment schedule, all of that. You could encode it into a smart contract. And then once those conditions are met, boom, the contract automatically executes the payment. No need for lawyers, no banks, no middlemen.
So it's like having a digital escrow agent, but it operates completely on its own, based on rules you set beforehand.
Precisely. And that's just, one example. Think about things like supply chain management. You could use smart contracts to track goods as they move around the world. So you always know where they are, ensuring transparency and authenticity, or even like voting systems. Think about like secure, tamper-proof elections,
Mm.
all powered by this blockchain technology. The potential here is just, it's pretty vast.
This is where it starts to click for me. So we've got this decentralized platform, right, running on smart contracts.
Yeah.
But what about like the fuel that keeps it all running? That's where ETH comes in, right?
You got it. ETH or Ether, it's the native cryptocurrency of the Ethereum network. It's like the energy, the fuel that powers the whole system. You need ETH to pay for transactions, execute smart contracts, interact with dApps. It's kind of like gas that keeps a car running.
So those gas fees I've heard about, those are basically just the cost of using the Ethereum network.
Exactly, yeah. Every action, anything you do on Ethereum, it requires a small fee. It's paid in ETH, of course, and it goes to the miners, or, well, now it's the validators who maintain the whole network. But here's the thing. ETH isn't just a fee, it's also a valuable asset in and of itself, like owning a stock in this decentralized company.
Right, because the value can go up and down
Yeah,
based on supply and demand like any other crypto.
precisely. But what makes ETH different is that it also represents the computational power and resources that actually keep the network secure and running smoothly.
Okay, I'm following along so far. So we've got the network itself, the smart contracts running on top of it, ETH as the fuel and a store of value. But you mentioned dApps earlier, and there are all these other tokens floating around too, right? How do they fit into all this?
Ah, yeah. That's where ERC20 tokens come in. These are basically the building blocks of Ethereum's, application ecosystem. Think of it this way. Each dApp can have its own unique currency, its own set of rules, functionalities, and it's all built on this Ethereum standard.
Oh, so it's kind of like those tokens you get in an arcade, right? Each game might use its own tokens, but they all work within the same like arcade environment.
That's a perfect analogy. Yeah, so ERC20 tokens are all built on that Ethereum standard, so they can be easily swapped and traded around, but each token, it serves a specific purpose within its own dApp.
This is where I get really excited about the potential. It's like a whole world of these decentralized applications, each with their own economies and rules, but they're all interconnected by this underlying Ethereum infrastructure. Give me some examples. What can you actually DO with all of this?
Well, one of the most exciting areas is decentralized finance, or DeFi. Imagine accessing financial services like, lending, borrowing, trading, but you don't need a bank or any traditional intermediary. That's the power of DeFi.
Wow, DeFi, that sounds revolutionary.
It is. And it's all powered by smart contracts. Imagine you could put up some crypto as collateral, and boom, you get an instant loan. And the terms of the agreement are automatically enforced by the code. No paperwork, no credit checks, no waiting around for approval.
That's incredible. But what about risk? Is it safe to, put your money into these decentralized systems?
That's a great question. And it is important to remember that DeFi is still relatively young. It's evolving, right? There are definitely risks involved, just like with any investment. But platforms like AVEF, they're working hard to make DeFi more secure, more accessible, offering a whole range of lending and borrowing options with, transparent rules and risk management tools built in.
So it's like any new financial frontier, right?
Yeah.
There's potential for big rewards, but you got to do your research, understand the risks involved.
Exactly. But DeFi is just one part of it. Don't forget about NFTs or non-fungible tokens. These are unique digital assets, and they can represent anything. Digital art, collectibles, virtual real estate, even real-world assets like event tickets.
Right, NFTs. They're everywhere these days.
Yeah.
But I'll be honest, still trying to fully grasp what makes them so special. Are they really more than just expensive JPEGs?
Absolutely. NFTs are about verifiable digital ownership. Imagine like owning a piece of digital art. And you can actually prove that it's the original, you can easily trade it, sell it, all on a decentralized marketplace.
So it's like having a digital deed or a certificate of authenticity, but it's permanently recorded on the blockchain.
Precisely. And this opens up so many possibilities. Think about owning a virtual item in a game. And you can actually trade it or sell it to other players. Or even owning like part of a song or a movie, right? With the rights and royalties attached to it.
Wow, the implications are pretty mind-boggling. What are some examples of like cool NFT projects that are pushing the boundaries beyond just the art world? I know the outline mentioned 3.
Yeah, so one project that stands out is Azuki. It's this anime-inspired NFT collection. It's got a super vibrant community, and they have this whole metaverse called The Garden, where holders can interact, attend exclusive events, all that. And they've also kind of pioneered this concept of physically backed tokens. So you can actually trade your NFT for a real-world item, like a limited edition skateboard, for example.
Wait, so you're telling me I could own a digital collectible, and that gives me access to a virtual world a real-world item?
That's the power of NFTs, yeah. They can bridge that gap between the digital and physical worlds in some pretty amazing ways. And they can also empower creators, give them more control over their work. Think about musicians selling NFTs that actually give fans ownership of a song and a share of the royalties.
That's incredible. What about the other 2 projects?
Oh, right. So there's also World of Women. They're all about celebrating diversity and female empowerment in the crypto space. Holders get access to exclusive art, events, and even opportunities to collaborate on creative projects.
Love that. It's so cool to see projects using NFTs to promote like inclusivity and community. What about that last one?
Right. So there's OMG Kirby. It's a really fascinating project. Basically, it lets you own a piece of music history, but on the blockchain. Each NFT represents ownership of an original song, and that includes the master recording and the publishing rights.
Wow, that's next level.
Mm-hmm.
Okay, so we've covered DeFi, we've covered NFTs. It seems like Ethereum has its fingers in every pie imaginable, but it's also facing some challenges, right? I've heard a lot about like high gas fees, scalability issues, all that.
Yeah, those are definitely valid concerns, and it's something the Ethereum community is actively working to address. The network's constantly evolving. Developers are working on solutions like Layer 2 scaling to make transactions faster and cheaper.
Layer 2 scaling. That sounds pretty intriguing. We'll have to dive into that more later. But for now, I think we've laid a pretty solid foundation for understanding the basics of Ethereum.
Yeah, I think so. I mean, we've only scratched the surface, but hopefully you're starting to see why Ethereum is such a groundbreaking technology with the potential to really revolutionize so many aspects of our lives.
Absolutely. And the best part is, this is just the beginning. Ethereum is constantly evolving. There are so many exciting developments on the horizon. We'll be back to explore those in the next part of our deep dive. But for now, let's take a little break, let all this information sink in. Welcome back. So last time, we kind of laid out the big picture of Ethereum, right? Decentralization, smart contracts, and all the different applications it can support. We even got into some real-world examples, like Avav for DeFi and Azuki for NFTs.
Yeah, it's like we took a quick tour of this whole decentralized city, seeing all the amazing things people are building and doing with it. But now I'm curious about the infrastructure, like the nuts and bolts that make everything actually work. How does Ethereum actually process transactions and stuff? That's a great question. Let's take a closer look then at the Ethereum network. Imagine you're sending some ETH to a friend, right? You open up your Phantom wallet, put in their address, hit send. Seems pretty straightforward, right?
Yeah, just like sending an email. But I have a feeling it's way more complicated under the hood.
Oh, absolutely. Your transaction, it doesn't go directly to your friend. It actually gets broadcast to the whole Ethereum network, and then it kind of joins this pool of like pending transactions,
Yeah.
all waiting to be processed.
So it's like dropping a letter into this giant decentralized mailbox.
Yeah, I like that analogy. Now, these transactions, they need to be bundled together and added to the Ethereum blockchain, which is basically this permanent tamper-proof record of every single transaction ever made. And this whole process, it's called mining.
Ah, mining. Isn't that where those like super energy hungry computers come in? I remember reading something about Ethereum's environmental impact.
You're right. So traditionally, Ethereum used a proof-of-work consensus mechanism. Basically, miners would compete to solve these complex math puzzles, and that's how they add new blocks to the blockchain. But this process, it takes a ton of computational power, right? Which means, yeah, high energy consumption.
So how is Ethereum addressing that? I know you mentioned proof of stake before.
Exactly. Ethereum recently went through a major upgrade. They call it the merge, and it basically transitioned the network to proof of stake. So instead of miners, now we have validators, and they stake or lock up a certain amount of ETH to participate in adding these blocks to the blockchain.
So it's like they're putting down a security deposit to make sure they behave.
Yeah, something like that. Validators get chosen to propose new blocks based on how much ETH they have staked. So this eliminates all that energy-intensive mining, and it really reduces Ethereum's carbon footprint.
That's a big deal. So Ethereum isn't just innovating in technology, they're also being responsible about the environmental impact. But how does this proof of stake system, how does it make sure the blockchain is secure and everything's legit?
That's a great question. With proof of stake, the security really comes from the economic incentives. So if a validator tries to cheat or mess with the system, they risk losing all their staked ETH, and that creates a strong disincentive to do anything shady.
So it's like a self-regulating system. The validators, they have a vested interest in keeping the network running smoothly.
Exactly. And because this blockchain is distributed across like thousands of nodes all around the world, it's incredibly resilient. Even if one node goes down, the network keeps chugging along.
This is seriously impressive.
Mhm.
We've talked about miners, validators, proof of stake. But I still have one question. How does Ethereum actually prevent someone from, say, double spending their ETH
Mm.
or creating a fake transaction?
Well, that's where the magic of blockchain comes in. Every transaction is like cryptographically secured, and it
Oh,
gets
yeah.
permanently recorded on the blockchain. So once a transaction is added, it's virtually impossible to change it or reverse it.
So it's like this public ledger that everyone can see and audit,
Mm.
making it really hard to cheat the system.
Exactly. And this transparency, this immutability, that's what makes blockchain technology so powerful and so transformative.
This deep dive into the inner workings of Ethereum is seriously fascinating.
Yeah.
It's amazing how this whole decentralized system works, without any central authority, but it's still so secure, thanks to all this clever stuff with consensus mechanisms and cryptography and all that.
It really is a testament to the developers and the whole community. It's all about community-driven innovation.
But we're not quite done yet, are we?
Hmm.
We still need to talk about those layer 2 solutions you mentioned. Those sound really important for, like, dealing with the high gas fees and scalability challenges.
You're absolutely right. Layer 2 solutions are key, and we'll get into all the details in the next part of our deep dive.
All right, listeners, stay tuned. We'll be back to unravel the mysteries of Layer 2 scaling and dive into the future of this incredible technology. See you soon. Welcome back to the final part of our Ethereum deep dive. It's been quite a journey so far, right? From the basic ideas of decentralization and smart contracts, all the way to how the network itself actually works.
Yeah, and we even explored the exciting world of, DeFi and NFTs, seeing how they're changing finance, art, and even ownership in this new digital age.
But there's one last piece of the puzzle we need to talk about, something we've touched on before, but it's so important it deserves its own spotlight. Gas.
Right, gas is like the lifeblood of the whole Ethereum network, keeps everything running smoothly, securely. But it's also been, a bit of a headache for some users because of those gas fees.
Okay, let's break it down then. Remind me, what exactly is gas, and why do we need it?
Well, you can think of gas as the fuel that powers every action on the Ethereum network. Sending ETH, executing a smart contract, even minting an NFT, it all requires some, computational effort. Gas is how we measure that effort. and how we pay for it.
So the more complex the transaction, the more gas it'll require.
Exactly. Sending a simple ETH transfer, that's like driving your car a few blocks. But deploying a fancy smart contract with lots of conditions and moving parts, that's more like a cross-country road trip. It needs way more fuel, which in this case is gas.
I like that analogy. But why do we need this gas system in the first place? Why not just make transactions free?
Well, imagine what would happen if transactions were free. Anyone could just flood the network with tons of spam transactions,
Yeah.
clogging everything up for everyone else. Gas acts as a sort of deterrent, make sure only the meaningful transactions get through.
So it's like a toll booth on a busy highway. The fee helps keep traffic flowing smoothly.
Exactly. And these gas fees, they don't just disappear. They go to the miners. Or now with proof of stake, it's the validators, right? And
Yeah.
they're the ones responsible for processing transactions and securing the whole network. It's their reward for all that effort.
Okay, that makes sense. But you mentioned earlier, high gas fees have been a real issue for some Ethereum users. What's being done about that?
Well, that's where those layer 2 scaling solutions come in. Remember how we talked about Ethereum being like a busy city? Layer 2 solutions are like building a network of expressways around that city. You can travel faster, cheaper, without clogging up the main roads.
So they're taking some of that transaction processing off of the main Ethereum blockchain, making things more efficient.
That's it. And they do it all while keeping things secure and decentralized, like the main Ethereum network. It's like delegating tasks to specialized teams just to improve overall productivity.
Pretty smart. What are some examples of these layer 2 solutions, ones that are really making a difference?
One of the most popular ones is Polygon. Think of it like a multi-lane expressway. It's got a variety of scaling solutions for all sorts of different uses. If you're a developer building a dApp, you can use Polygon to lower those transaction costs for your users.
So Polygon is like a toolkit for developers, giving them more options to make their dApps faster and more affordable. What are some other layer 2 solutions we should keep an eye on?
There's Optimism, which is all about reducing costs while still working with, existing Ethereum applications. And then there's Arbitrum, which really prioritizes scalability and security, uses fancy cryptography to make sure transactions are processed quickly and safely.
Wow, it sounds like a whole ecosystem of solutions, each tackling those scaling challenges in their own unique way.
That's the beauty of the Ethereum community. It's so vibrant and innovative, always pushing boundaries, always looking for new ways to make this technology accessible and efficient.
Well, this has been an amazing journey, exploring the world of Ethereum with you, learning about how it all works, and the incredible things people are doing with it.
I'm glad you enjoyed it. And just remember, this is just the beginning for Ethereum. It's constantly changing, evolving, with new developments popping up all the time. It really is a game-changing technology. It has the potential to, completely reshape how we live our lives.
For sure. And if you're ready to dive in and explore the world of Ethereum for yourself, remember to download Phantom. It's like your passport to this whole new world.
And be sure to stay tuned for more deep dives into all the exciting stuff shaping the future of, everything. Technology, finance, culture, you name it.
Until next time, keep exploring, stay curious, and dive deep.